Okay, welcome everyone. This is the week 4 webinar. And today what we're going to do is the normal distribution. So one of the good news is that this is one of the easier weeks in terms of new material because what we're going to be doing is the normal distribution, which isn't that hard, but I kind of lightened it up this week a little bit. A couple reasons. One, what's due on Sunday?
Exam.
Yeah, exam. And that's, so when I say it's a light week, it's not a light week, it's just a light amount of material that's new. So you have the exam, and then what's due the following Sunday?
Project 1.
Yeah, project 1. So we got some big stuff coming. So I figured it's a good week to have a little bit of a lighter week in terms of new material. So we're going to have the exam project 1. And again, that doesn't mean you should be starting the project in a week and a half, because the idea is like in about 9 days or so, hopefully you can send me your full draft, you're written out, and then I'll tell you how to improve on it. And hopefully everyone has a project idea that you have submitted and pushed on the project discussion board. So I can look at it and, give you advice. Almost everyone needs a little bit of something. I know we had one disaster group in my other stats class that they did a survey question that was, are you vaccinated? What's the problem with that as a survey question for the project? Yeah, it's qualitative. So that's really important. That makes it a complete disaster, by the way. Do not do a qualitative survey question. And had they talked to me a week ago, then I would have helped them and gotten them through. But their project's due earlier than yours. So anyhow, so I wanted to give you a big warning. Do not do a qualitative survey, because that just doesn't work. Qualitative is not what this project's about. So anyway, let me talk about the plan today, all the different things, or the few things that we're doing. Let me share my screen. And oops, there we go. So let's talk about the plan of the day. I'll start out as always for questions, if you have any questions. And also, if you have any questions throughout, you can ask too, but I always like to start on general questions first. Then we'll talk about the standard normal distribution. And it's a big deal. The hard part is that this week you will not see why it's a big deal. Next week is the big theorem that tells you why just about everything you do in statistics follows the normal distribution. But that is not something we're going to get this week. This week, you just have to trust me that this is the important distribution. Mathematically, it's really intense, but we don't have to deal with the hard mathematics. But you do have to deal with the shape and a few other things. So we'll talk about how do you calculate probabilities and percentiles when you have a normal distribution. Okay, so that's a big question you're going to need to find the probability that blah, 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 if it's a normal distribution. And we'll do a bunch of examples. Then we'll talk about the normal distribution. That's the general normal distribution. With the general normal distribution, we will definitely need to use the calculator in a big way. Even with the standard normal, a lot of things need the calculator, but not everything. And we'll talk about calculating probabilities and percentiles when we have a general normal distribution. And the good news is the calculator does it for you, but you have to know what to put in. Okay. So that's the good news. If you had to do it by hand, it wouldn't be fun. Trust me, it would be, unless that's what you love to do, but I doubt it. It's brutal. And then after that, we'll do some applications, an application or two. But again, the real applications really happen starting next week, and then and then continuing on pretty much every week starting next week are applications of the normal distribution. Okay, in one way or another. Sometimes they're like sneakily at normal distribution. You don't even notice you're using it, but that's what you're using. So that is pretty much, like I said, the rest of the course uses this normal distribution. Okay, or most of it. So that is the plan. It might be a little shorter than a normal webinar. Usually people don't complain too much about that. It's not because I'm in a hurry, but I might run out of things to say, and you might not have any questions, after that, and then we'll call it a night. So we'll see how it goes. So let me ask you, are there any questions about anything? You can pop in the chat box, you can talk, whatever. I'm always happy to answer.
We had a quick question.
Mhm.
And I didn't understand if this was for the example or if it's a rule, which is the standard normal distribution. They said the mean is 0 and the standard deviation is 1. But that's not a rule? That's just that problem?
No. That's when you have the word standard, and that's what I'm about to talk about, actually.
Okay.
That's the word standard.
Okay.
Whereas number 4, the general normal distribution, means that you're going to say, well, that you don't have to know the mean and the standard deviation. But for the standard normal distribution, the mean is 1, and the mean is 0, and the standard deviation is 1. And there's a reason for that. And the reason is it's the easiest. You might think, well, why can't you let the standard deviation be 0 too? Because that's an easier number. But do you know what happens if the standard deviation is 0? Yeah, it means that every single data value is the same number. Because that means there is no variation from the mean. So everything is the same number. So you can't let the standard deviation be 0. So the easiest number other than 0 is 1. And hopefully y'all agree with that. So that's the reason why it's the standard normal distribution. When I first taught this class, which was before many of you were born, we didn't have these kind of calculators, and we had to do it using tables of a standard normal distribution. It was just miserable. So it was really important in the old days. Now it's not. It's still important for a few reasons, because it makes life easier to kind of talk about stuff. But the good news is now that we have good solid calculators, some that I programmed, you don't have to use a standard normal distribution for everything. And again, if you're not following, that's okay, because we're about to talk about it. Okay, other questions? Questions, anyone? Any questions? I see in the chat box line. I don't know what that's about, but okay. If there's no questions, let me give you the picture of the standard normal distribution, because that is very important. Yeah, let's do that. So here is kind of the picture of most of the stuff you want to know about the standard normal distribution. So the first thing is the mean is 0. And the shape of the distribution is this. So it starts really low, and then it goes up high pretty steeply. Then it flattens out at the top, and then it goes down pretty steeply, and then it lowers and flattens. It never ends. So even though it says 4 and it doesn't have, a 5, it actually goes out forever. But once you pass 4, there's almost nothing under the curve anymore. You have to go like a bunch of decimals out to even see anything. So pretty much between -4 and 4 is just about everything. Even between -3 and 3, you can kind of see there's very little past 3 of this colored in stuff. So the standard deviation is 1. And that was the answer to your question. So here's the mean at 0. The standard deviation is 1. And that's this value. I'm going to say this fast. If I say something fast, you know what that means? In this class? It means you're completely not responsible for it. So you don't have to listen, but some people like to hear. So yeah, so the equation for the standard normal distribution is 1/√² 2 pi sigma times e to the negative x minus mu squared over sigma squared. Got it? So this is a curve, and it has a formula, and that was it. If I said it fast, that means you don't have to worry about it at all. Got it? Okay, but here's what you should know. And this is the empirical rule, which was talked about in, I believe, the chapter 2 video. And that is for the standard normal distribution. If you look at the probability of being between -1 and 1, which is the same as the area under the curve, that is a 68% probability, or 0.68. If you look at the probability of being between -2 and 2, that's the area under the curve, that is a probability of 95%, or 0.95. And if you look at the area under the curve from -3 to 3, then that probability of getting in there is 99.7%. So you can see when you get to -3 and 3, you got it. That's like almost all of the probability is in between those. Just a note, and you're not supposed to know this, but maybe you can guess. Which of the 3 are most important, do you think? One of these is much more important than the others in terms of that you should have in your brain for the rest of the whole class. Which of the 3 numbers? Just take a guess if you don't know. Okay. I see you not all guessing, but you could guess. Madeline got it. So 95%. So 2 standard deviations from the mean is the 95% probability. And that becomes really important in a few chapters from now when we talk about confidence intervals, because that's kind of the standard amount of confidence that you want, is you want to be 95% confident that you're right. And anything outside of that is not so good. And in fact, if you're past 2 standard deviations, do you remember what you call something that's past 2 standard deviations? Yeah, not a potential outlier, an outlier. Not even potential, it's an outlier. That's the definition of an outlier, is 2 standard deviations farther on the left or the right. And then over 3 standard deviations, we call that an extreme outlier, you can see, because it's very, very unlikely. Do you see that? So those are words that you need to know, and we've talked about them already, but we just haven't shown it with this picture yet. Any questions at all about this graph, this picture, and this distribution? Okay. It's very different than the uniform distribution. Who remembers the shape for the uniform distribution?
Rectangle.
Yeah, that's a rectangle. And those are like wonderful in terms of easy mathematics, because base times height, you all know the area. On the other hand, the area under this curve is not something like any of you know, except maybe Braulio, if you still remember. But it's brutal. It's not just an integral, it's full power series and all kinds of messy stuff. So we're not going to, you will not be responsible for finding the area unless it happens to be between -1 and 1, then it's 0.68. So if it's one of these guys or something that is related to that, you can do it. But if it was, say, between 0.3 and 0.9, you're not going to be able to do that one. Okay, not without a special calculator. So any questions on this? And this has other words. So kind of the simplistic word for this, who knows what this is? That most people know, not people that haven't had stats. They've heard of it. Yeah, bell curve. Okay, so simplistic word is called the bell curve, and you've probably heard the bell curve. The normal distribution curve is what we'll be using in our class. There's another language that you'll hear sometimes, it's called the Gaussian. And that's because there's a guy named Gauss that came up with this. So historically, that's why. Where did this come from? Gauss. Gauss came up with this. So he was one of these like super brilliant guys, I don't know, over 100 years ago. And he figured all this stuff out. Yeah, he's definitely in the top 2 or 3 of the smartest mathematicians in the history of the world. And he was just amazing what he came up with. So that's where it came from, is Gauss came up with it. And you've seen this shape in the real world. Where have you seen something that has a shape in the real world physically? Yep, a mountain. Okay. So a mountain often has this shape, especially on the, not as much in California, but on the East Coast. Do you know why? It's geology, not math, but it's part of this distribution. Let's talk about rocks. Those mountains are older. So what happens, yeah, erosion, when things settle down over the long run, you get a normal distribution. And that's the reason the East Coast is older than the West Coast in terms of the geological construction of the mountains. Okay. Also, if you ever go to the beach and you like take sand and you drop it and you just kind of slowly drop it, that's the shape it falls in, right? Yep. Waves actually turn out to be a little bit normal, but they're a little bit more called sine waves, and I'm not going to go there. Okay. Hourglass is a little different too. Hourglass is, I think I'm just not going to get into it because I don't want to scare y'all, and you don't need to know it. But if you drop sand slowly, that will give you that shape. Okay, so it comes up in physical stuff all the time, but it comes up even more for what's called sampling. But let's do some examples where you have to calculate. Okay, so part A is, let's suppose that Z follows a standard normal distribution. That means that picture. Use the empirical rule for the following. Find the probability that Z is between -1 and 1. And you should all be able to easily do this from the picture. What's that probability? Yeah, 68%, or better is not 68, but 0.68. Probabilities are always between 0 and 1. So it's better to do it that way. So the probability, probability that -1 is less than Z is less than 1 is equal to 0.68. Okay, and that's just from the picture. Any questions on that? Okay, the next one, we got to do some more thinking. What is the probability that Z is less than 3? So we want the probability that Z is less than 3. Okay, and this one you got to think a bit, because we know between -3 and 3, what is that probability? Yeah, that's 99.7. Actually, it's 0.997, always between 0 and 1. So you always want to turn it into a decimal. So that's 0.997. But the problem is that's not enough, because what we found is between -3 and 3, but then there's a little bit to the left of -3. Okay, Colin got it, but let me do the whole, process. So then we got to get between -3 and -infinity, or -infinity to -3. And the idea is that we call this a left tail. If you take the left tail and add the right tail, you should get what's left over between -3 and 3. We want just a left tail, and the left tail is half of the leftovers. So I'm going to add 1/2 times the leftovers. The leftovers, well, between -3 and 3 is 0.997. So if I say not between -3 and 3, how do you find that? Remember the rule for not. Yeah, it's 1 minus. So it's 1 minus 0.997. Any questions on that? And that, if you pop in a calculator, is 0.9985. or do it by hand, or however you want to do that. Any questions on that example? So kind of a little bit of geometrical thinking is you're putting pieces together and adding up their areas. All right, let's look at part C. Now let's find the probability that Z is between -1 and 2. So probability of -1 less than Z less than 2. Kind of similar thinking. So the idea is we can say, well, take the stuff between -1 and 1 first. And that is the 0.68 that we already found, right? But then we also have to get that between 1 and 2. And that's this piece right here. Any questions on that? And the idea is very similar, that this piece and this piece combined is going to be the area between -2 and 2 minus the area between -1 and 1. So if I have the two pieces and I want only one of them, I add a half of the double. And again, if I take the area between -2 and 2, which is 0.95, and I subtract the area between -1 and 1, which is 0.68. Anybody lost on that, on what happened? So 0.68 is this middle part.
I have a question.
Yeah.
So the theory of this in general is that in order to find the answer, we're kind of adding or subtracting or like using the pieces to figure out what the other ones are. Okay.
Yeah. And we're going to do it with a calculator soon, but I want you to see where all these numbers are coming from. Okay, so, and then let's see if you can pop in a calculator. Tell me what you get. Hopefully you can all do that, because you are responsible for knowing how to use a calculator. You can try to do it in your head, but that's kind of a pain. Calculators are better for this. Okay, 0.815. Any questions on that? Okay, so the next question, part D, is find the value of Z. No, this is not the Z-score calculator. We're going to see it's not a coincidence we call it Z, like Z-score, but you really want to think of it as a different concept. It's definitely not a Z-score calculator. This is normal distribution stuff. So find the value of Z such that there is a 2.5% probability being greater than this value. So here's what we do. So let me pop on the next page. So we got the picture. So the idea here is that if there's a 2.5% chance of being greater than the value, is the value large or small? Yeah, it's large, right? If 2.5% of the people are taller than you, you're a tall person, right? You're not short. So that's one way when thinking about it. Okay, so one thing is it's going to be over here somewhere on the right. And the idea is if there's 2.5% greater than, we can do the mirror image over on this side and say there's 2.5% on this side, kind of extreme on the other side. What's 2.5% plus 2.5%? 5%. So if there's 5% on the two tails, how much is in the middle? 95%. And look at that. There's the 95% goes between -2 and 2. So what's our answer? So what's the value of z? 2. Because we're on the high side. The high side of this 95% interval is 2. So the answer is 2. Let's put a 2 there. Okay, and then the next one is find the 16th percentile. So that's the same idea, except if you're in the 16th percentile, are you in the high side or the low side? Yeah, then you're on the low side. So now we're over here somewhere. But same idea, there's 16% now lower than you. Then on this side, there's 16% high on the right extreme side. What's 16% plus 16%? That's 32%. So if there's 32% on the two tails, how much is in the inside? That's 68%. So now we can answer our question. If you're on the low side and you're in the edge of the 68%, what's your value of z? Yep, -1. So here the answer is -1. Any questions on this reasoning? Okay, so just a note, because it was asked about z-score. Let's suppose, just for fun, let's suppose we looked at a number, the z is, say, 1.3. Find its z-score. Without using a calculator, you don't need one, trust me. Because what's the mean and what's the standard deviation? And that, remember, that's part of this big standard normal distribution. Yeah, so what is the z-score? The hint is it should not be hard for calculation. Yeah, 1.3, because you subtract 0. What's 1.3 minus 0? You better all know that. Yeah, 1.3. And then you're supposed to divide by 1. What's 1.3 divided by 1? 1.3. So the answer is 1.3. Okay, and there's nothing special about the number 1.3. I can give you any number. So if you happen to say what z is, that is the z-score. And that's why we use the letter z for the standard normal distribution, because its value is its own z-score. Okay, and that only happens when the mean is 0 and the standard deviation is 1. Any questions at all on any of these examples of kind of seeing the geometry of the standard normal distribution? Okay, if not, let's continue on. All right, so now we're going to do a general normal distribution. So now suppose that x follows the normal distribution with mean 114 and standard deviation 23. Notice it's no longer a standard normal distribution. Now it's a general normal distribution. We don't use the letter z, we use letter x. Okay, so we use x if it's just some general normal distribution, and we use z if it's the standard normal distribution. Any questions so far? And the question is, find the probability that x is between 100 and 120. Okay, if I asked you to do this by hand, you should just yell at me. Okay. because not going to happen. Got it? Doing these by hand is not going to happen. So instead, what do we do? Yeah, we go to the calculator. So let's go to the calculator. And that is, I just have to find it. I think that's down lower, actually. Let me find it again. There it is. LibreText calculator. And what number do you think I'm going to be looking at for the calculator? Number 8. So again, I tried to put these in the order of at which we do things. And I tried to name them with the name that is what we're doing. And we're doing the normal distribution. So you're going to hit normal probability. Okay. And it says fill in all the values except 1 below and hit calculate. And then the last value will be given to you. So you can leave anything blank and it gives you the last value. Normally, you're going to either leave the low, the high, or the P equals blank. That's typical. I don't think there's anything that you have to do in this class where you leave the mean or the standard deviation blank, but it could be done. That was actually hard to program, but I programmed it for that. All right, so let's look at the example. That one. Let's pop this over here. So first thing, the mean is 114 and the standard deviation is 23. So the mean is 114. Standard deviation is 23. Any questions so far? We want the probability that X is between 100 and 120. So where do I put 100? That's supposed to be easy. Yeah, that's the low. And where do I put 120? That's the high. And the P equals the one I leave blank because I want the probability and I don't know it. And I hit calculate. And just a note, you never really need that many digits. For the homework, 4 is usually enough. 0.3315. So maybe I'll pop that in. Any questions at all on finding this probability? Did it look pretty easy? Okay, if you ever have any suggestions on how to make it like even simpler, let me know. But I do my best. Okay, now the probability that X is greater than 200. That one's a little different. Okay, so again, we want a probability, so the P equals we leave blank. And again, we want greater than 200. So what is the lower bound for greater than 200? Okay, 201 is a good guess, but this is a continuous distribution. And 200.5, for example, is greater than 200. 200.1 is greater than 200. 200.000001 is greater than 200. So the lower bound is 200. Any questions on that? Okay, what's the upper bound? What's the biggest number greater than 200? Yeah, infinity, but infinity is not a number in a calculator. So what you do is you bring in enough standard deviations above the mean so that there's nothing to the right, basically. So here's my suggestion is look at the numbers we've got. And the biggest number of these 3 numbers is 200. And in particular, that is 3 digits, right? add 2 more and make those 9s. So I'm going to put in 5 9s. So my recommendation is take the number that has the most number of digits and then add 2 more digits and make them all 9s. And that will always be so many standard deviations above the mean that the calculator won't know the difference between that number and infinity. Any questions on this idea? And then hopefully calculate, that's an easy thing to hit. And you get, is this sufficient for the margin of error in doing the homework? Yes. Yeah, so if you do more than 5 9s, if I did 11 9s, that's fine too. Because that makes it even bigger, even closer to infinity. Do you see? So yeah, so if you did 6 9s, no problem. But if you only did 2 9s, that's definitely not okay. Because 99 is not close to infinity in relationship to 200 and 114. It's not even bigger than those. So that's why I recommend 2 more 9s than the number of digits. Any questions on that? So the answer, let's go 4 significant digits, and that 2 should be a 3 if you can do that, because I'm going to round. And make the 2 a 3 for round off. Any questions on that example? Okay, now let's do the probability that X is less than 90. What's the right bound? I'm going to start there this time. I can get rid of the P because we don't want that. Yeah, that's 90. How low can you go if you're less than 90? Okay, you can go low. You can go lower than 0. -1 is less than 0. Remember that the standard normal distribution even has negative numbers, right? Yeah, so negative infinity is as low as you can go. And you look at these numbers, and that is the largest, right? Don't worry about negative signs. And we don't have any, but if we did, don't worry about negative signs. So we have 1, 1, 4. So that means you're going to need 5 9s. But we want to be on the negative side. So it's negative and then 5 9s. And then I'm going to hit calculate. And to 4 digits, 1, 4, 8, 3, and the 3 becomes a 4 because it's rounded. Any questions on this example? It's very easy if you know what to do. So practice. All right, look at D. So find the probability that X is greater than 105. Do you remember how do you read this little vertical line thing? Good try. It's not or. Yeah, given. So it's find the probability that X is greater than 105, given that X is less than 125. So now you got to remember a formula. And that is the probability of A and B. Maybe I'll put it over here somewhere. Is equal to the probability of A given B is equal to the probability of A and B divided by the probability of B. Okay, and that was in chapter 3. Okay, by the way, just because we're in chapter 6 does not mean you're allowed to forget everything else we did. Things come back just when you least expect them. Okay, so what we do is we need to find the numerator and the denominator. We're going to use this calculator twice. So this is going to be the probability of being greater than 105 and less than 125, which is the same thing as 125 is less than X is less than, that's right, 105 is less than X is less than 125. Is that clear that that's the and there? If you are greater than 105 and less than 125, you're between 105 and 125. And then you divide by the probability that X is less than 125. And then it's calculator work. So 105 to 125. So we want the probability, erase that, put 105 for the low, 125 for the high, and hit calculate. And that's 0.33598, etc., or about 0.336 if you round to 4 decimal places. Divided by, we need to be less than 125. So 125 is now the high, and the low is going to be negative a bunch of 9s. And 5 is enough. Probability we don't know. So hit calculate. And there's our probability. 6838, because we got to round up. So 0.6838. And then I don't want to waste your time. Then you throw it in basic calculator. Did I lose anyone there? I will give you a warning. It's much easier to watch me do it than to do it yourself. My guess is if I just asked you guys to do part D and didn't give you any hints, a lot of you wouldn't have been able to get there, but maybe you would. But my experience is most can't. Most need help. So you want to practice. Okay, then part E is find the IQR. Who remembers what IQR means? It's important for your project. Yeah, interquartile range. So that, if you remember, is Q3 minus Q1. Any questions on that? So now we go to our calculator. What does it mean to be Q3? Yeah, what about 75th percentile? Where does that 75 go on the calculator? It's not the low. It's a good try. Where does it, which of these boxes? There's 5 boxes. It's not the high. 3 more guesses. So where does the 75 go? Which of the boxes do you put it in? Since it's the 75th percentile. Yeah, that's the P. And you want to write probability, not percent. So it's going to be 0.75. And which is the one we don't know? Turns out we know the low. The high is one we don't know. The low is negative 99999, is negative infinity. Because it's from negative infinity to that high should cover 75% of the data. And then I hit calculate. And I get 129.5133. And then we do the same thing for the 25th percentile, but now P is 0.25. And the high, we'll find out. Hit calculate. And we get this baby, 98.4867. Any questions on that? And again, I don't want to waste your time. You can subtract those of the calculator. Any questions at all on A, B, C, D, or E? Okay. So let's go to F. So the middle 84% of the data is between what two values? So that was a little bit, you got to think a bit. What if I asked you the middle 50%? So the idea of the middle 50%, that is the interquartile range, right? And that's 25% of the left, 75% right of the right side, left of the right, I guess. So similarly with the 84%, if there's 84% in the middle, let me write this in. Then how much is outside? Yeah, 16% is outside. How much is on the left? Yeah, 8%, half of that. 8% is on the left. And now we're ready. So if there's 8% on the left, then we can now put in 0.08 over here, just like we did for the quartiles, because now we're looking at the 8th percentile. And the high is what we don't know. And you get this value here. And round it to 4. Okay, now that was the left. So that's if the left bound of that is 8%, what would the right bound be? Yeah, 92%. So then I go over to my calculator, and instead of 0.08, I do 0.92. And of course, erase the high. Oops, got an extra point. There we go. It'll let you know if you screwed up. I gotta get rid of the NaN. NaN means not a number, by the way. It means you screwed up. And there we go. Okay. So we go that to that. So 81.6834 to 146.3166. Any questions on that? All right. So now find the z-score for the value that x is 117. So the idea here is we're given the mean and standard deviation, so it's easy. Again, the mean is, where are we? 114, the standard deviation is 23. And you could use a z-score calculator if you want. Okay, so your question is, what if the data is discrete instead of continuous? The answer is, then there's no normal distribution you can even talk about, because normal distributions are continuous. We will learn that if there's a large enough amount of stuff, sometimes you can approximate, but that's later. That's next week. But if you have discrete, it's not normal. And we're only dealing with normal. And that is continuous. So hopefully that makes sense. So for the z-score, you just take 117 and you subtract the mean, which again is 114. And then you divide by the standard deviation, which was, I believe, 23, but let me double check. Yep, 23. I mean, you could use a z-score calculator too, but I don't know. I'm going to use Google's calculator. I'm going to copy and paste that. And 0.1304. Any questions at all on finding the z-score? Okay, so now let's do an application. All right, so this is kind of a fun one. All right, so suppose that the time until you or your wife, if you're male, give birth, is normally distributed with mean 140 days and standard deviation 7 days. Okay. By the way, if your mean is 140, what's the simple way of saying that? What do you ask someone? That's the answer to what question? Nobody asks a pregnant woman, what is your mean? Yeah, how far along are you? Or when are you expecting is another way of saying it. Okay, so just let you know that, I tried to give you something that's actually applicable. And the interesting thing is, in the old days, the standard deviation was 7 days. Do you know why it's changed? This is not a math question. The hint is most of it's a 1-letter answer. Some of you want to be nurses, so you should know this. Not seeing y'all jump in. C-sections. And C-sections have changed what the standard deviation is for giving birth, because that changes how long it takes before you have a baby, right? Because if they have a C-section, that means they pulled it out earlier than your naturally was supposed to come out. Okay, but it's a good thing sometimes you have a C-section. I'm not saying that those are bad, but it has changed the standard deviation. But so for natural births, it actually is 7 days, kind of a week. Okay. You think that would be excluded as an outlier? Yeah, maybe. I don't know, but I'm just saying what it is. There's a lot of C-sections nowadays. I don't think they're outliers. Yeah, they come up too often. Okay, so anyhow, that's the mean. So the mean just means that, 140 days is what you expect. And the standard deviation is a natural birthing standard deviation for women. All right, so now your boss has just scheduled you or your wife, if you're male, for a business trip to China. Good idea? Okay. All right, you or your wife leave today. Got it? And will return in 135 days. Find the probability that your baby will be born in China. Okay, any questions on the question? Okay, so what we need to do with this is the first thing, and I'm going to do it from here, is we need to talk about the distribution. So the first thing, do we use X or do you use Z for this situation? Yeah, this one's an X because Z is for only standard normal, and this is general because we don't have a mean of, of 1 and standard deviation. I mean, mean of 0 and standard deviation 1. Because that would be weird. That means you are giving birth now. I mean, that just can't happen. Okay. So instead, we use X, typically capital when we're talking about a whole distribution. And then I use the following symbol. And we talked about this, I believe, last week, didn't we? And that is the tilde symbol. Okay, it's like shift, and then it's just to the left of 1 is what you click on. And that means has the distribution of. And then I use the letter N. Hopefully you can all guess what N might stand for. N doesn't stand for sample. That's not the first letter of the word sample. Not number. Normal. There we go. Normal. This week is all about normal distribution. And then I'm going to put in 140. That's the mean, comma 7 for the standard deviation. Okay, so if I say write down the distribution, this is what you're writing. Any questions on that so far? Okay, we want the probability that what? Yeah, born in China, but in terms of, variables, yeah, less than 135 and actually greater than 0. Turns out that 0 doesn't matter. But let's not even go to the 0 because that's just confusing. So X is less than 135. Okay, because if X is less than 135, that means the baby's born in China. If X is greater than 35, you have returned. Any questions so far? So now that we have that, we have all the information we need. 140, 77, and 135. So go to the calculator. So you can put in negative 99999. You can put in 02, it'll give you the same answer, it turns out. And then again, 135 was our high. The mean was 140. And the standard deviation was 7. And then P is what we want to find out. So we leave that one blank. So again, please ask if you have any questions. And we hit calculate. And we're looking at, I'm gonna do the nearest whole number percent, 24%. What do you think? Would you be okay with that? Okay. Most wouldn't. All kinds of issues if your baby's born in China. Lots of problems. I don't think your baby could become president if your baby's not born in America, for example. And don't you want your kid to become president of the United States? So there's lots of issues. Okay. Yeah, naturalized doesn't count. In the Constitution, it says you have to be born in America, in the United States. That's Constitution. That you don't have to be. It's not about being a citizen. It's about being born in the U.S. So Arnold Schwarzenegger can't be president. For example, he was able to be governor because that's not in our Constitution in California, but in America that is that he wasn't born in America, even though he's a citizen. Okay. So you might say probably not good. And again, if you're a guy and you're going to be the dad, you probably want to be there for the birth. I'll tell you, that was really important for me to be there when my daughter was born. I would not be okay not being there. So here's B. Okay, you decide it's too risky. Got it? And you want to negotiate with your boss. And you want to ensure that there's no more than a 1% chance, because that sounds more reasonable, doesn't it? There's no more than a 1% chance that the baby will be born in China. What day should you ask to be the return date? Any questions on the question? So we want no more than a 1% chance. So 1%, where does that go? Yeah, there's our P. And don't forget, don't write 1. What should I write? Yeah, 0.01. What's blank? Yeah, the high is the blank. Okay. And the low could be negative 99999. That's fine. And then we'll find out a return. 123.7. And if we want no more than a 1% chance, then you need to return on day 123. You need to round down. There's a special case where you don't use the rules rounding because you don't want to push a little bit over 1%. You want to make sure it's less than 1%. So that means return on day 123. Any questions on that? Okay, part C. Okay, so you went to China, talked to your boss, you returned, and now it's 138 days later from when we did this calculation, and the baby still hasn't been born. Find the probability that the baby will be born in the next 24 hours. So what is this? How do I create this as a probability? (138 to 139). Okay. So that's one thing, is we have 138 to 139, but there's a little more to it. It's not the probability of being between 138 and 139 with that mean and standard deviation. What's the problem? Why not? And it turns out 135 has nothing to do with this anymore. Yeah, it's conditional on being after day 138. So in other words, this is the probability that X is between 138 and 139, given that X is greater than 138. Any questions on that? So it's a conditional because we know the baby's not born yet. So that means it went 138 days without it being born. We know that. That's a given. Then we can use that rule again. And that is the probability of A and B. Okay, notice that being between 138 and 139 and being greater than 138 is the same thing as just being between 138 and 139. Okay, if I tell you that I am over 50 years old and I'm in between 50 and 60, what do you know about me? You know I'm at least 50, but you also know I'm at least 50 and between 50 and 60. But you didn't need to hear the at least 50 because I already told you I'm between 50 and 60. So similarly, if you want to find between 138 and 139, given greater than 138, is just the same as between 138 and 139. So that's the probability that 138 is less than X is less than 139, divided by the probability that X is greater than 138. So let's go 138 to 139. That's the low, is 138. The high is 139. Probability is what we want to find out. And there it is, 0.05565. And then we divide it by probability X is greater than 138. So now the low is 138. What's the high now? Yeah, 5 nines. Whoops. There we go. Probability is what we want to find out. Hit calculate. And 6125, rounded. Pop that in a calculator. And it's about a 9% chance. Any questions on that? Any questions? Yeah, 99999 would be a long pregnancy. Yeah, I like that. That's why we can get away with putting those in, and even though it's officially infinity, because infinity and 9999 are the same things for pregnancy. Okay, any questions at all on this example? Okay, one more example before we call it a night. Okay, so you have an ice cream store. Okay, I know it doesn't work so well in January, but you know, maybe you have an ice cream store in Peru or something. Okay, you have an ice cream store, and suppose the amount of ice cream that you sell each day is normally distributed with mean 950 ounces and standard deviation 120 ounces. Find the probability that a randomly selected day you will sell between 900 and 1,000 ounces of ice cream. Okay, so the first thing I always like to do, it's very important, is we have x tilde n, and then the mean was 950. The standard deviation was 120. Any questions on that? Then you don't have to read that top sentence ever again, because we've got the information we need. And we want the probability that we're between 900 and 1,000. Is that clear? So let's do it. 950 to 120 is our mean and standard deviation. We want the probability to be between 900 and 1,000. And let's leave P blank. And there we go. About a 32% chance. Okay, very important in business to come up with these kind of probabilities, because it helps you understand how much ice cream you need to have in your stock, because that's important. So let's talk about the next question, which kind of gets into that. In the morning, you took stock of your supplies and notice that you have 1,100 ounces of ice cream in your store. What's the probability that you will run out by the end of the day? What does it mean to run out? For your business, what does it mean happened if you ran out? Yeah, you sold out, and in particular, your customers combined wanted more than 1,100 ounces. So if they wanted more than 1,100 ounces, you're going to run out. Whereas if they want less than 1,100 ounces, you don't run out. Any questions on how to read that? So we want the probability that X is greater than 1,100. So then we just go to our calculator. Greater than 1,100, the low is 1,100. The high, okay, how many nines do I need? Yeah, 6 this time. And leave our probability, hit calculate, and about 11% chance. So probability is, 0.1056 or about 11%. Okay, part C. Okay, the problem is, are you really going to be okay with running out of ice cream 11% of the days that you sell ice cream? If you're a business person and that happens, you're going to have a lot of bad reviews, and bad reviews are really bad for business. So let's suppose you want to be 99% certain that you're not going to run out of ice cream so that you really don't get a lot of bad reviews. How much do you need to have in stock at the beginning of the day? Any questions on the question? So now where does the 99% go? Yeah, that's our P and not as a 99, but as a 0.99. So we want to be 99% certain. And what is the low? Zero. Okay, you could also put negative 99999 in since it's normal. Zero will work also, it turns out, but I'm just going to put a bunch of nines. The high is the one we don't know. And if you calculate, it says 1,229 ounces of ice cream. Any questions on this example? So again, very important in business to know what your clientele wants. Okay, because you want to make sure that you have a good reputation. And you collect data, you realize that you have a normal distribution. We'll get into that next week on why that's going to be the case. And then you can do the calculations. So since that's the last example, what do you think we get next? Yep. So the secret word is unimodal, because the shape of the normal distribution is unimodal, right? It has one lump at the middle. So that's why I was trying to give you something relevant that you probably wouldn't guess if you were just guessing what the secret word is. Do you think any of you would guess this one? I doubt it. So that's always my plan. But something that maybe you'll remember why it's important. So as I mentioned, we're earlier than usual because today's a lighter day. So I'm going to stop the share and stop the recording.